Over the next few videos, we're going to focus in on thinking about intermolecular forces. Right? So as the name suggests, these are forces that exist between two different molecules, right? So inter meaning between two or more molecules versus intra, which means forces within the same molecule. Okay, so we're thinking about two different compounds, right? Let's make one green here. Interacting with a different molecule will make this pink color. Right? So if we have two different molecules and they come into close proximity, the forces that hold them together as, let's say, as a liquid or as a solid are known as intermolecular forces, the forces between molecules. All right? In all cases, the forces that hold molecules together are based on the interaction between charges. Okay, so we're concerned about interacting charged particles. So this video is specifically going to think about the origin of interactions between charged particles. Okay, so whenever we're dealing with two or more charged particles interacting, the force that attracts them or repels them is known as Coulomb's law. Okay, and in its simplest form, Coulomb's law tells us that the energy between two particles, okay, and I'm going to put a sub P here, this is potential energy. So this potential energy is proportional to the charge on one particle times the charge on another particle divided by the distance between them. Okay, so for example, if we're thinking about two positive charges, right, so this red particle is a positive charge interacting with another positive charge, you should know that these two particles should repel each other because they have the same charge, right? So according to Coulomb's law, this potential energy should be proportional to +1, right, the charge on the first particle, times +1, the charge on the second particle, divided by the distance between them, which in this case is the distance from the center to the center. So this is our radius here. Okay, so as we can see here, I have a positive number times a positive number divided by the radius, which is positive. So in situations when particles repel each other, Coulomb's law tells us that this potential energy is greater than 0. It's a positive energy. Okay? Let's think about what happens when we have a positive charge interacting with a negative charge. Let's make negative yellow here. Okay, and same thing goes. So the distance between these two is the radius, right? It's from the center of one molecule to the center of another. This is the radius. So in this case, our potential energy is going to be proportional to the charge on the positive particle times the charge on the negative particle divided by that distance. So in this case, our potential energy is less than 0. Okay, so what this means is that when it comes to the interaction between molecules, a favorable interaction is negative. An unfavorable interaction is positive. So any interaction that's negative is a good thing. We'll give it a little smiley face here. Anything that's positive is not so good. Okay? Keep this in mind as you're working through and you're thinking about the interactions between particles. So let's think about this law in a little bit more detail, right? Because what this predicts is that as two charged particles get closer and closer together, right? So let's keep this example in mind, where we have a positive charge and a negative charge coming into close proximity. What Coulomb's law in this form predicts is that as they get infinitesimally close, right, these things get closer and closer and closer, then this potential energy gets more and more and more negative, or more and more favorable. Okay, so Coulomb's law in the form that we've drawn it out would predict, right, so if this is the y-axis here is our potential energy, and this is the 0 spot. Okay, as we've drawn out Coulomb's law, it would predict that as the radius, so this is our radius here, as the radius gets larger and larger and larger, this potential energy gets closer and closer to 0. But as you get close to a radius of 0, we would predict this to get infinitesimally negative. Okay? But in reality, if we think about what happens when the radius approaches 0, right? So when the radius approaches 0, I have my positive charge and my negative charge. If the radius is 0, this means they lie on top of each other. And according to Coulomb's law, that would be a really favorable interaction. But in reality, we know that that's not practical because two things cannot occupy the same space. So Coulomb's law only partially explains the real interaction between molecules. Okay. We can actually take this graph and kind of adjust it to account for what Coulomb's law fails to include, or at least what we are failing to include in Coulomb's law. So Coulomb's law predicts that we get more and more negative as the radius gets smaller and smaller, but at some point we have to reach, right, so at some point we have to reach what we call a potential well before this potential energy starts getting more and more positive as the particles get closer and closer together. Okay, so this spot right here, this radius, is where the potential energy is the most negative, right? And where this potential energy is the most negative is the most favorable distance for these two particles to be apart from each other. If you get closer together, then they start repelling each other because they start overlapping and existing in the same space. But as you get further and further apart, right, so as we go in this direction, Coulomb's law tells us that as you get further apart, the particles don't feel each other as well, so the stabilization energy is not as negative. And it's this idea that governs all of the intermolecular forces that we are going to discuss. Okay? In the next video, we'll introduce all of these intermolecular forces, and we'll see how they're all very much related to this idea of Coulomb's law.